With our large agricultural and food production sector, Ireland is in a great position to exploit bioenergy, and researchers are already starting to rise to the challenge. I'm here in Ballinasloe, County Galway, to find out more about a world-first waste-to-energy technology that brings the phrase waste not, want not to a whole new level. By the end of 2018, Ireland's dairy farms are expected to produce more than 7.5 billion litres of milk. That's a huge level of production, but also a significant level of waste. Wastewater from dairy processing plants contains organic compounds, nutrients and pollutants, so it has to be treated before being discharged into rivers and waterways. And that's where NVP Energy comes in. Michael Murray is Managing Director. What's the traditional way that this wastewater has been treated?
That would be aerobic technologies. They are highly energy intensive in nature. They're large cylindrical tanks or large rectangular tanks where there's oxidized bubbles which break down the organic matter, converting that into a sludge, and then the water is cleaned up to a stage that it can be eluted then into the local river or to the local sewer.
And you have developed a new way, a new technology in order to treat this wastewater.
Yes, we've developed what's called low temperature anaerobic digestion. And what that simply means is we have developed a specialized type of microbe that was developed in the lab at the National University of Ireland in Galway that breaks down the wastewater pollutants at a non-temperature dependent level. So normally those microbes, like what's in your stomach, normally have to work at above 30 degrees Celsius, but the microbes that we use can work as low as 4 degrees Celsius.
Dr. Dermot Hughes helped develop NVP's unique waste-to-energy technology at NUI Galway.
The technology is the culmination of 12 years of, I suppose, applied research within NUI Galway, and then 3 years of extensive R&D by the company itself when they commercialised the technology.
And it had to be collaborative. You've got the bio element of it, but then you needed the engineering part to upscale it.
Absolutely, yeah. And that was one of the challenges when the company took over the patent from the college, was that it's all fine and well doing it at lab and pilot scale, but this is a whole different kettle of fish. As you can see here, this is a full-scale process.
Anaerobic digestion involves the breakdown of organic material by bacteria in an oxygen-free environment. The concept has been around for centuries, but the innovative aspect of this technology is that the microbes can get to work on the waste at low temperatures.
The wastewater is pumped in through the bottom of the reactor and passes up through a bed of microorganisms, and that's where the bulk of the treatment takes place. So that's your removal of your polluting potential, and your generation of your biogas takes place in that area of the tank. Then as the wastewater continues to be pumped up, it passes through our patented anaerobic filter section. So this is a secondary stage of treatment within the process, and that's what really polishes the effluent to a very high standard. Okay. Wastewater continues then to overflow out of the tank. In comparison to the conventional activated sludge process, which relies on aerobic microbiology, this process is significantly different. The old process, while it worked very well, it was a very energy-intensive process. You also had the generation of a significant amount of secondary biomass or sludge that needed to be processed and managed. So with our system, you reduce that, but you also have significantly less energy input went into our system, typically 10% of what you would use in a conventional system.
Wow, so that's a massive improvement on the amount of electricity we would need to clean the wastewater.
Certainly, and that's not the only benefit. You also have the benefit of generating a usable fuel in the form of biogas from the process.
The biogas that is produced can be used as vehicle biofuel or to produce carbon-neutral heat or electricity. Rebond Dairies were one of the first to take up the technology, and Jerry Ryan is their quality and technical manager.
We had a conventional aerobic activated sludge plant. It was reaching capacity. We were growing the business here, so we needed to do an extension.
And what was it that convinced you to adopt a new technology? Because that can be quite difficult for a business to do, take on something new and you're not quite sure if it's going to be beneficial.
It was a bit of a challenge, but the college developed a test rig, did about 5 litres per hour, but we had it on site for 3 months, and it actually did what the lads in the college said it would do. The big driver for us was energy cost. This is a very low energy operation. There's practically no sludge generated, so there's no cost on sludge disposal. The process is working, we're getting good treatment, we're generating a biogas.
So you're saving money and you're saving the planet.
So far, so good, yeah.
Efficiency is the name of the game these days. You know, energy is a big problem. Energy independence is a big problem, and that's where this technology really fits in. It's a really good fit for this sector in the sense that you get energy out of it as opposed to putting energy into it. Ultimately, the goal here is to have a carbon neutral treatment plant where the energy you're producing is enough to drive any of the other processes within the plant. Well, it's very exciting. I mean, a lot of PhDs and postgraduate studies, in theory, they do a lot of nice benchwork, but it never really gets to a full-scale system. So it's absolutely great to see it come to this stage.